Hi everyone, in this video we are going to talk about the sum and product of the roots of a quadratic equation. So if our quadratic equation is like this, let's say ax squared plus bx plus c is equal to 0, then the roots of the equation are like this. X equals negative b plus root over b square minus 4ac by 2a, that is one of the roots. Let's say x sub 1, and the other root is x sub 2, which is equal to again negative b minus square root of b square minus 4ac whole divided by 2a. Generally, in quadratic equation theory, generally the roots are denoted using the Greek letters alpha and beta. So instead of using x1 and x2, what I'm going to do now, I'm going to change the names here. I'm going to name them as alpha and beta. These are the two roots of our quadratic equation. Now what would be the sum of those two roots? Let's take a look. So now we are going to calculate the sum of these roots, which is like alpha plus beta. Alpha plus beta will be negative b plus square root of b square minus 4ac divided by 2a, and then plus negative b minus square root of b square minus 4ac divided by 2a. So let's simplify this, and this will be equal to, the LCM will be 2a because the denominator on both sides or for both terms is 2a, so the LCM would be 2a, and for each of the terms LCM and the denominator, they are same, so pretty much we will have the numerators coming up here, right? So it will be negative b plus square root of b square minus 4ac, and then plus again negative b, or instead of saying the plus and negative b, I would simply say negative b again, because this plus and the minus, they become minus, so negative b, and then minus square root of b square minus 4ac, right, all divided by 2a. Now from here we can clearly see that this term, this positive square root term and the negative square root term, they're going to cancel out each other, right? So now we are going to be left with two negative b's here. So there is one negative b right here, and then another negative b right here, and that's about it in the numerator, and the denominator we have 2a, so it will be negative 2 times b whole divided by 2a, and that will be equal to negative b by a, because the 2 and the 2 will cancel each other, so we'll be left with negative b by a, and that is the sum of the roots of our quadratic equation. So this is the sum of the roots, and it's very important to remember it's negative b by a if our quadratic equation is ax squared plus bx plus c equals 0. Alright, now let's try to derive the product of the roots. So if we have to calculate the product of the roots, suppose we have to calculate alpha times beta, right? We have to calculate this product. So let's see how it comes out. So our first root is minus b plus root over b square minus 4ac whole divided by 2a, and then our second root will be minus b minus square root of b square minus 4ac divided by 2a. So from here, let's now remove the parenthesis, and in the denominator we will have 2a times 2a, so this will be 2a times 2a, that will be 4a squared eventually, and then in the numerator we have negative b plus square root of b square minus 4ac times negative b minus square root of b squared minus 4ac, right? And now let's try to simplify this. So in the denominator we have 4a squared. Now here in the numerator, if you carefully look at it, you see that we have something plus another thing multiplied by something minus the other thing, right? So it's like x plus y, it looks like x plus y times x minus y, where x is actually the negative b and y is actually the square root of b square minus 4ac. So if you think of them as x and y, so it's clearly x plus y multiplied by x minus y. Do you see that picture? Now this actually becomes x squared minus y squared. This is actually x squared minus y squared. So in our case, it will be like this. So in our case, it will be negative b squared, meaning negative b whole squared, minus the square root of b square minus 4ac squared, whole squared. So let me erase this. If we simplify this, in the numerator we're going to get, so negative b squared will be b squared, the negative will become positive because we are multiplying negative b by negative b, that will become positive b squared, and then we will have a minus sign, and then here we are going to get b squared minus 4ac because we have a square here and a square root. So the square and the square root, they will nullify each other, they will cancel each other. So we are going to be left with b squared minus 4ac, right? And in the denominator we have 4a squared, and from here you can see that this will simplify to b squared minus, let's remove the parenthesis, so it will be minus b squared and plus 4ac. The negative 4ac will become positive 4ac. And then in the denominator we have 4a squared, and this is from here you can see that the b squared term will cancel out each other, on positive and negative they will cancel out each other. So we are going to be left with 4ac divided by 4a squared, which is 4ac divided by 4a times one more a, that's the a squared. And then again, as you can see, 4 will cancel out each other, the a, one of the a's will also cancel out each other, right? So now you can see we are left with c by a, and that is the product of the roots. So far we have seen the sum of the roots came out to be negative b by a, and the product of the roots came out to be positive c by a. So let me sum it up again. Let me create a little summary here. So alpha plus beta was negative b by a, and alpha times beta is equal to c by a. Now let's take an example and we'll see how to solve certain problems. So suppose let's take an example. Let's say suppose we have a quadratic equation which looks like this. Let's say x squared plus let's say 3x plus 2 is equal to 0, right? So if we are asked to find the sum of the roots of this equation, then for this particular equation, as you can clearly see that the leading term, which is the x squared term, has a coefficient of 1. So that means here our a, which is the coefficient of the leading term, is actually 1, and then b is actually the coefficient of the x term, which is the middle term here and which is positive 3, and then c is the constant term, which is positive 2. So this is our ABC for this particular example, right? So now if we have to calculate, let's say if we have to calculate the sum of the roots, so I'm writing right here alpha plus beta, it will be negative b by a, so that will be negative, and then what is our b? B is actually 3, so that is b divided by a is actually 1, so this is actually negative 3. So the sum of the roots would be negative 3, and what would be the product of the roots? Let's do product of the roots. Suppose alpha times beta would be c by a. So what is our c in this case? C is actually 2 and a is 1, so the product of the roots would be 2 divided 1, that is 2, that's positive 2, right? So this is how you can calculate the sum of the roots and product of the roots when a quadratic equation is given. Or sometimes you could be given a quadratic equation with a little unknown there. And let's take a second example. Suppose we have a quadratic equation where we have an unknown there, right? So suppose x squared plus 3x plus c is equal to 0, but we have been told that the product of the roots in the problem, they have provided that alpha times beta, the product of the roots alpha times beta is equal to 2, for example, right? Let's assume that this is what has been given in the problem. Now we have to find out the value of c. So the question here is find c, find the value of c. So how do we do that? Well, the product of the roots have been provided, so alpha times beta is equal to 2. But from the equation, what is our product of the roots? Our product of the roots would be c by a. So the solution is now, the product of the roots would be this c right here divided by a right here. A is actually 1. 1 is hidden. 1 is generally not written in algebra. If there is no coefficient, you assume that there is a coefficient 1, right? If there is no coefficient, the coefficient is 1, right? So what is our c by a in this case? So in this case, the product of roots is equal to this c right here divided by 1. And also in the problem, they have provided the value which is positive 2. They have provided the value of the product which is positive 2. So now all we have to do is we have to say that our c by 1 is equal to 2. And from here we can say that c is equal to 2, right? And that is our answer, which is accurate, I suppose, because if you look at our previous example where we had the 2, I pretty much, for the second example, I pretty much took the first example and then I made the 2 an unknown constant there, and then I provided the product of the roots which was 2. So I kind of created the second question from the first question itself. So here we can verify that yes, the value of c comes out to be 2, and that is accurate because the second example is exactly same as the first example. So if you are given the quadratic equation with everything known there, no unknown constant, then you can easily calculate the sum of the roots and the product of the roots. Now if you are given an equation with some unknown constant, however they provide you the product or the sum, then from there you can calculate the unknowns. I hope it all made sense. Thank you for watching. See you in the next video.